Good morning, good afternoon, good evening, as some of my colleagues would say. To all you ladies and gentlemen, here we go. We're going to do a video here now on just reviewing polynomial rules. So this is what we're going to do. In order to add them in the first section here, we combine like terms. We don't touch the exponent. So I've got 3x squared plus a negative 6x squared. Notice they are both x squared terms. Same variable, same exponent, so we can combine them. 3 of them minus 6 of them. You take the coefficients and add them. You get negative 3 of them. Never touch the x squared. Kept it the same. It's like 3 apples minus 6 apples is negative 3 apples, okay? Subtraction, same thing. Combine like terms. Do not touch the exponents. You can fill that in. And it works the exact same way. I've got a 14y cubed, so minus 6y cubed. They are like terms, meaning y cubes and y cubes. So the coefficients, 14 minus 6 of them is 8. When we get to multiplication, we multiply the coefficients. And we add the exponents. Some of you guys know that as multiply the bigs, add the littles. So I got a 3x squared and a minus 6x squared. They do not have to be the same exponents on the variables. We've multiplied the bigs, that's the coefficient, so 3 times negative 6 here gives me negative 18. And I add the littles, x squared and x squared, 2 plus 2 make 4. Okay? Talk about more of those, again, in reviewing in class. Then, when we get over here to division, what do you do with the coefficients? Of course, you do like you always have. You divide them. That hasn't changed since you learned division back in 3rd grade. So we divide the coefficients. That's the numbers out in front. So in this case, the 18 and a 6 in a moment. And we subtract the exponents. So it's exactly what we're going to do. I have 18 divided by 6. Division is 3. And then with the exponents, they don't have to be the same again, unlike adding, subtracting. So what's 10 y's in a sense? Y to the 10th power minus y to the 3rd. 10 minus 3 gives you 7. Those were your basic rules. So let's rewrite those down here. If I got an x to the a right here times x to the b, when we're multiplying, we keep the base and we add the exponents is the rule. When I raise a power to 1, this is called the power rule. You got to remember, it's a little different. That's the case when I raise a power to power that I multiply the exponent. So that's a special case. You can always expand whatever number times that b is on the outside. Here's one. A lot of kids, even my older kids, forget what's anything to the 0 power. You need to know that is 1. I don't care if it's a billion to the 0, negative 5, whatever. When we're dividing, we just did up above. What do? We divide the coefficients out in front. In this case, we're on any. And I have the bases here, so I have the same base. I subtract, which would make sense, because if over here, when I multiply, I add, it should make sense when I divide, I subtract. And finally, when we take a look at this, x to the negative a, not too much right now. When you get to algebra 2, we use it a lot. You've got x to the negative a. We can rewrite it as the reciprocal, flip it up 1 over x to the a. So the negative sign forces you to flip it. If it's a negative in the bottom, it comes up to the top. If it's a negative like this in the top, because this is technically over 1, you flip the whole thing. So remember to flip. Okay, those are some of your basic rules. Let's take a look at some more stuff and some examples. Alright, in our second slide here, we're basically going to take polynomials and multiply them using box. We call that the box method. So you place the polynomials, each 2 terms. Let's see here, I got 2 terms here on the side, and I got a trinomial right here, so binomials with 2 terms. Trinomials got 3, which I placed across the top. They're on the outside of the box. And then we're going to use our multiplication grid here with our rules we just talked about to multiply and fill in the boxes. So, if I take a look at this here, I've got in the upper left-hand corner of this box right here, I've got 2x squared. I got to take this times this. Well, what are our rules? Multiply the bigs, so what's 2 times 4? 8. Add the littles, x squared and an unwritten x to the first, so that means that's x to the 3rd. Okay, then I go to the next one right here. I'm going to take the negative 4x times the same 4x to the 1. Well, negative 4 times 4 is a negative 16. X times x, 1 plus 1 makes 2. And then I've got negative 2 times 4x is a negative 8x. Nothing's going to happen to the exponent there because all I got is that one little x. Now we're going to move to the next box. I take my 2x squared again, but this time down in the next row times 5. There is no exponent, so 2 times 5 is 10. And x squared stays the same there. The next one here we move on. Negative 4x times 5. Just match them up. You've got a negative 20x. And finally, the last one, negative 2 times 5 is negative 10. I have filled in my box. Now what we do is on an angle, we're going to actually come on out. So if I move this on diagonals here, come on out. If I have nothing to go with that, that's 8x cubed. So that's the one diagonal, so that's part of my answer, 8x cubed. This one here on the diagonal, and you're looking at the diagonal going this way, 10 of them and a minus 16. I need my adding rules, so they're like terms because they both are x squared. I get a negative 6x squared. 10 of them minus 16, so that's a minus 6x squared as part of our answer. The next diagonal, a negative 20x and a negative 8, make a nice negative 28x coming out. They are also like terms, so we just add the coefficients, keep that variable. And finally, the lowly little minus 10 here is on the end, and you have done it. We multiplied a binomial times a trinomial, and we have what we call in general a polynomial. It turned out to be all the way with 4 terms. Degree 3 is our biggest exponent. Okay, that's the box method. Okay, folks, so now what are we doing? We just did the multiplying, dividing, adding, subtracting that. And, of course, we want to do the opposite of multiplying that, and that's going to be called factoring. First two I want to look at, the big one we know is GCF. So you better start this guy. You need to know this guy. You always need to try this first before thinking of any other method, okay? It says to divide each term by what? Yes, the GCF. So you got to figure out what's the greatest common factor. And if you forgot where the greatest common factor is, which by the way you're going to pull out and place in front, if I want to take this thing right here and find the greatest common factor, remember math, num, tab over to num, 9. It'll give you the ability to punch in the 12, comma 16 if you don't know how to find the biggest number that goes into both 12 and 16. In this case, they told you it's a 4. You put that 4 out in front, and then you turn around and divide both these guys by 4. So 12x divided by 4 is 3x, and 16 divided by 4 is 4. And you have officially factored by GCF. Remember, sometimes it's more than numbers. You got variables that come out. As far as the variables, make sure you pick the lowest of all of them. So if you have like an x to the 5th and an x to the 3rd, the smallest one is x to the 3rd, so you can take 3x's, x to the 3rd out on every one of them. That's GCF. This one I'm going to talk about, I'm still going to talk about dots. We still love it, even though we kind of got rid of it this year and that. Difference of, I call it DOPS, difference of perfect squares, but they call it the difference of the squares. You find the square root of each part. So if I've got something that looks like this, okay, it has to be the difference, so we have a minus sign in there. And they got to be perfect squares, such as x squared is a perfect square because it has an even exponent. And 16 we know is 4 times 4. And then, so you got to find the square root of each part of the polynomial. Okay, and all I have to do is this. X squared we said was x and x, so I put an x out in front and an x out in front on the other one. Then one has to be plus and one's minus. They got minus and plus. I like plus and minus. It doesn't really matter either way. So they put that in the middle. And then, of course, the square root of 16 is equal to 4. And you should know 16 is 4 times 4. And that will work every time when it's the difference of perfect squares, or in this case, the difference of the squares. All right? Great shortcut method. At the same time, if you don't want to know that one, you can go with the last thing here on that, on the regular methods we talk about, which covers them all, other than GCF, which you must do once again first, GCF first, okay, is the AC method. So let's go take a look at that. Alright, folks, AC method with the X box. So when we do this, this is for all, including the DOPS I just showed you. But you got to take a look. You got to remember this thing is in an ax squared plus bx, ax squared plus bx plus c form, equaling 0. That's a typical quadratic. So my a is the coefficient out in front, in this case an unwritten 1. the b is a -2, and my c is equal to -24. Then we play with those numbers in order to come up with our factors. So, what you guys like, a lot of you, is the X box. If you those that don't, you know what you're doing, just go with the factors, that's fine. I'm going to do the X box off to the side here. The X box starts with the A and the C on the top, the B on the bottom. So the A times the C is 1 times -24, so that goes into this part of the X box. And the B, of course, is a -2. Well, now you need to know your factors, and you learn some tricks on how to do it on the calculator. If I do it by hand and you're not sure, come up with the factors of that AC, 124. I know I have 1 times 24. I know I have 2 is next times 12. I go in order. Does 3 go in it? Yes, it does, times 8. 4 times 6, and the only thing left to round the horn here is a 5, which doesn't work. So one of those 4 factors, which all of those multiply to get the AC up here, so we're all set there. But I need to get a -2 here, and this was a subtract. So which pair subtracts the 2? And it turns out to be 4 and 6. So I have a -6x on the one and a 4x on the other. And that -6 times -4 or times 4 gives me -24, and -6 and the 4 make down here the b, the -2. So then we basically set it up by grouping in that. We bring our first thing down again, so I have an x squared. Then come back over here and take those pairs that we just came out of if you use the X box. And so that's a -6x and a +4x. And then the last piece here, the -24, that equals 0. Now we're going to factor by grouping. So I have my first group right here. What can I pull out GCF-wise? Correct, they share an x to pull it out. If I divide by x, I'm left with x. If I divide the -6x by x, I'm left with a -6. Then I got my other pair right here, 4x and a -24. Obviously they share a 4. If there's a minus here in front with that 4, you would pull a minus out. In this case there isn't, so I'm going to just put the +4. That's what I'm pulling out. And you divide them both by 4, which leaves me with the x, and I get a -6. And what better happen is this pair right here, the thing in parentheses, better be the same. So when I go to do that, I have that pair, the x -6 that they have in common, and the stuff that was out in front, the x and the +4, make my other factor. And that's how you factor ACM method. If you want a solution, I'll bring that up here. You take that x -6 times the x +4 equals 0. Like you want to find your zeros in that, we do, and tee it up. So the set x -6 equal to 0. Bring the 6 over, and you'll get +6 as one of your zeros. And x +4 equals 0. Bring the 4 over, you will get -4 as your other zero. So that's the AC method with a little X box in there, factoring by grouping, all that good stuff. That's how we factor polynomials.